All right. So since I see this as a word problem, I'm going to use our word problem solving techniques that we're going to go through. Read the question, find the question, which is at the end, trim the fat, which is going to look for units or mathy words, and then we're going to circle the numbers. Okay? Now, so this one says, find the last question, or find the question, and here it is right here. Obviously, no, select the one is not the question. So I go above, it says, below are various solutions that your group mates arrive at. Select one that's correct. And so what we're doing is we're looking for solutions. Okay, looking for solutions, and the problem is it doesn't give me any units of measure. And so what I'm going to do now is I'm going to go up and I'm going to circle the things that are numbers. All right, and so here's one set that has numbers in it. Okay, and now in math or in algebra, letters also represent numbers, and this R has a unit of measure of radius. Okay, and so as I look through here, we're taking this right here, R for radius, and we're solving for R, is what I see out of this problem. Whether I read all this in here, I don't give a crap that it's volume. I don't need to know that my group is rearranging it. I see the R, and I see that I'm solving for R. So I'm going to take the equation that we have up here, and I want to get the R by itself. That's what I'm doing. I'm solving for R. Because it doesn't give me any numbers to plug in over here to get a value. And so since I don't have any numbers that I circled, I know that I'm just working on getting a variable by itself. And so what all is on there that I got to get off? The first thing that's on there is this is a fraction. I don't want to deal with fractions, so how do I undo this fraction? Now, this is an order of operations problem. Okay, just a second. We're going to multiply by 3, but this is an order of operations problem because what I'm trying to do is get this by itself. So I'm going to get the 3 off of there by multiplying. So that gives me 3v equal to 4 pi r cubed. What do I know about 4 pi? Are those numbers? If I put 4 times pi in my calculator, do I get a number? I do, right? Because this is a symbol that represents the fraction 3.14. Okay? And so therefore, if those are numbers, how do I get them off the R? Well, they already are multiplied, aren't they? Right, so I'm going to divide by them. Okay, and so I'm left with 3v divided by 4 pi equals r cubed. How do I get rid of that cube? That's where we come into an issue. What if it was squared? How do you get rid of a square? Last year you probably didn't have geometry, but you probably did enough work that you probably had to use a formula of Pythagorean theorem that you plugged into. And at some time you had to get rid of the square, and you took the square root of it. And so, since this is not a square root, we're going to take a cube root. Now, we just talked about fractional exponents a while ago, so if I have r cubed like this, what if I raise it to the 1/3 power? We just talked about fractional exponents where the power is the 1, the root is 3, so this is going to become, when I do the power rule, 3 over 3. What does 3 over 3 reduce to? It's going to be r. And so that's what we're doing over here by taking the cube root of it. But if I do the cube root to one side, I have to also do the cube root to the other side, right? And so what I'm left with for my solution is the cube root of 3 capital V all over 4 pi, and that's going to equal r. Okay? Is that one of my solutions? Which one is it? Look at the screen. There's what I got. Is it on the screen? Is it?
B.
It is B. B and C are very similar. What's the difference between B and C?
On C, the fraction goes all the way.
Right, so that's saying, C is saying that this 4 pi is not underneath the radical of the cube root. And we know that in my over here, that's wrong, right? So that's the difference.